Now, one thing that you might notice is that when we used the chain rule before, what we did was we replaced a sort of nasty looking section of our formula with a u. And then we said if we want dy dx, then we'll just change y, so it's in terms of u. We'll find dy du and du dx, multiply them together, and we'll have dy dx. Now, when we did that, remember how we made sure that we didn't put any u's into our answer? We subbed back in terms of x, so that when we found dy dx, it was always in terms of x, wasn't it? Whereas in that last example, we found dv dt, and it wasn't in terms of t, it was actually in terms of s, or we could make it be in terms of v. Now, that's because we didn't have information then about what was happening with time. We didn't know how big that square was at the start, and if we did, then perhaps we could have related that back in. But that's that subtle difference between the way we're using the chain rule now and the way that we were using it before. The way we're using it now, we're very much dictated by what the question is asking us. And we need to have our rate of change in whatever units we can muster, basically. So this example is similar, but just with some different formulas. We've got a spherical balloon this time, so a perfect sphere. We don't know how big it started, but it's got a radius of r and volume v, and it's being inflated. So let's imagine, for argument's sake, that it starts out virtually infinitely tiny, and it's just getting bigger. Now, if, this is a big if, we need to know one rate to be able to find another. In fact, we need to know two. We can deduce something because we know something about spheres, but we need an extra clue. So if the radius is increasing at 2 centimetres per second, let's think here of what they're actually telling us. That would be the change in radius over time, wouldn't it? So that's going to be 2, that's like a little clue. Find dv dt, in other words, the change in volume with respect to time, as a function of r. In other words, in terms of r. Okay, so let's tackle this first question. We want dv dt. We've got dr dt, and thinking that through is handy. So let's write down the one that we know, and then you can see which one you need. Now we need a dv on top, and we don't have that. So obviously we need that. And we need a dt on the bottom. We've already got it. We need this dr to cancel with something. And that's a nice, easy way of just double checking that when you multiply two things together, you're going to get what you're looking for. Now, this one we've already found. So we can see that that's 2. And now we need to multiply by dv dr, and we're a little bit stuck because we don't know what that is. I would do that working over on the side, because this is nice for getting you started and seeing what you need. And then when you need something, you can say, hold on a minute, I'll just figure that out, and then I'll come back to you and put it in the right place. So over on the side here, I would say, let's get a better pen. The volume of a sphere, now this is something you should know from year 10, 4/3 pi r cubed. Now we can differentiate volume with respect to r just by bringing the 3 down. It'll cancel with the 3 that's already there, so it'll disappear. We'll be left just with the 4 and the pi, and the r cubed will change to r squared, which you might notice now is actually the formula for surface area. Very curious, that's actually the derivative of the volume. More on that later. So now we've found that, we can toss it in over here where we need it, 4 pi r squared. And I like this working because it's really nice to be able to say this is this, and that's that, and I can see where that came from. And now I can just tidy up my answer, 8 pi r squared. At the end, we need to check, is it in terms of r? Yes. Does it have any units? Not yet. Well, let's think. This is volume of a sphere. It's changing over time. So it's going to be in centimetres cubed, and it's going to be per second. So we can add that in. For the second part, find the radius when the volume is increasing at 100 centimetres cubed per second. Now that rate of change of the volume, that's dv dt. So this time they've given us dv dt, so that's going to be 100. And we've got to find what the radius actually is. Okay, well we know that the rate of change of the radius is 2. So we can put that in again. And here, what we have is we've got 2 times dv dr being 4 pi r squared. So literally we're just subbing in what we need when we need it. So here we've got 8 pi r squared is equal to 100. Let's divide both sides by 8 pi to get rid of that. And I'm not going to actually do it, I'm just going to write it like that so I can do everything in one step. And that's r squared. So then r is going to be the square root of that. So if r, well let's write it like this. R is going to be the square root of 100 over 8 pi. Now there's numerous ways that you can express that. I can see there that I've got the square root of 100 on the top, and on the bottom I've got the square root of 8, which is 2 root 2, and I've still got my pi there. And now I can divide top and bottom in half, and I've got 5 over root 2 times pi. So if they ask for it in exact form, I'd give it like that. If they say round it to 2 decimal places, then I could do that too. In fact, I could do that well back here and save myself a little bit of time. And when I get to the end, of course, I need to make sure I add units and just read the question and check that you've answered it. Find the radius. So the radius will be this, and it would be in centimetres. Okay, for the second part of the question now, we've still got the first line, but we've replaced A with B, and this is a new if. Okay, so we need to ignore A, that's finished now, those conditions are gone. It's still a sphere, and so these things still hold true, and I've written them down again. We've got the volume formula, and we've differentiated the volume with respect to the radius. That still remains true. But now we say if the volume was increasing at this rate, find the rate of increase of the radius at a certain radius, or the radius when the whole thing was a certain volume. So I recommend always starting the same way. Start by writing down your basic this equals that times that statement. Now we know about the volume and how it's changing with respect to time. We also know what dV dr is. So I mean, you can put these two things in whichever order you like. I tend to write the things I've been given and then think about what the other thing is that I'm going to need. So here I know dV dr. So I can see my dV is there. My dr needs to cancel, so I need to put it on the top. And I need dt here. Okay, so what we're actually finding in both of these questions is the rate of increase of the radius. In other words, we need to find the change in radius over time for both of these. Now, if we like, we could start with this whole thing and say, look, I'm going to need to use it twice. How about I rearrange it? This is going to be that divided by that, isn't it? You could do that if you like. Let's go ahead and do it. dr dt is going to be dv dt divided by dV dr. Next, I'm tempted to put in what I know for both parts of these questions, which is that the rate of change of the volume, in other words dV dt, is 50. So for both of these here, really, I could have a 50 in here, and that helps to just make things a little bit more straightforward. Now, I also know what dV dr is. It's 4 pi r squared. So I'm dividing 50 by 4 pi r squared, which I could write like this, really. Probably be a little bit easier. Now I could tidy that up. I could write it as 25 over 2 pi r squared. Probably nice to keep it as integers rather than make it into 12 and a half over pi r squared, but it's up to you. There's lots of ways to do the same thing here. So for both of these questions, I've just found what dr dt is, but I found it in terms of r. So for part 1, where they say, well, what's dr dt when r is 7? I'm going to say dr dt is 25 over 2 times pi times 7 squared, because I'm just subbing in 7 for the r. Tidying that up, I can see this is 49 times 2, which is 98. So I've got 25 over 98 pi. And I can leave it like that pretty much, or if it's been asked to be rounded off to 2 decimal places, I could do that. So for the second part, they're asking me what dr dt is when the when the volume is a certain thing. 2 ways to do it. I could say, let volume equal 4500 pi and find r, and then once I've got r, I'll be able to just sub it into here. Okay, does that make sense? Let's do it that way to start with. So I've got 4/3 pi r cubed is equal to 4500 pi. I can divide both sides by pi. I can multiply 4500 by 3 and divide it by 4, or just divide it by 4/3, same thing. 4500 divided by 4/3 is 3375. So I can see that r cubed equals 3375. So the radius must be the cubed root of that, which is 15. That worked out nicely. Okay, so what they're saying is, in other words, when r is 15. So now I can say, when volume equals 4500 pi, brackets r equals 15, dr dt is equal to, and I've got my formula here for dr dt, it is 25 over 2 pi times 15 squared, and that gives me, well, let's just do the 25 over the 2 times 15 squared first, so we can tidy up the fraction. That gives me 1/18 if I put it in without the pi. And writing it like that is much simpler than if I put the pi in, and then it would give me a nasty decimal. So I've basically just put in 25 over 2 times 15 pi to see how many, what this fraction would be, and then I've just chucked the pi in afterwards. Of course, if they ask you to round it off, then you can just put the whole thing in your calculator and round it off to whatever the specification is. Now, I mentioned that there's always another way to do it. I could have just fiddled with the volume formula first to get it in terms of R, so that then if we said, all right, let's multiply both sides by 3 here and divide by 4 pi, that gives me R cubed. But if I want R, I can actually just take the cubed root of both sides. This now is a formula for the volume of a cube, but it's in terms of R, isn't it? And R is the subject, and it's in terms of V. So what I could actually do is just sub this in here, where the R goes, and I could say that dr dt is equal to 25 over 2 times pi times all of this thing squared. Now, pretty messy, 3v over 4 pi, and then I have to square that whole thing. Now, I could have used that formula, so that then when they say, hey, when the radius is this, what will dr dt be? I could just sub that in where the v is, and out would come my answer. Obviously, I could also probably tidy this up a little bit better too. My point here is that sometimes you'll have many ways you can get to the same answer. And if you're doing it a certain way because it makes sense to you, that's a great way, as long as you're getting to the right answer and the way that you went made sense. Don't be too concerned if someone beside you does it a different way, because there's many ways to do the same thing.